This video describes a programming assignment. Generate random integers in the range of 1 to 100 until 5 prime numbers are generated. Each number is displayed when generated. Prime numbers are identified when generated. The 5 prime numbers are then output to the display after the 5 prime numbers are generated. Here's a sample output. Begins with this text. This program generates 5 random integers in the range of 1 to 100 until 5 prime numbers are generated. So here's a random integer 94, then 82, 18, 41, and 41 is prime. So that 41 is identified as prime. And the program continues generating random integers. This time, when 29 is found, 29 is identified as prime. In the first group, the fourth integer was prime. In the second group, the fourth integer is prime. Here in the third group in this sample output, the second integer is prime. In the fourth group, the first generated integer is prime, 19. And here in the fifth group, you have 40, 12, 18, 94, and then 79, the fifth integer generated in that group, is prime. In the heading, 5 prime numbers found in 16 tries, and then the 5 prime numbers are listed. So what is needed to write this program? Well, first we need a loop, counting the primes while we're generating random integers waiting for a prime. When the 5 prime integers are found, we output this text, which includes the number of tries, 16. Let's see the 16 tries. 94 is 1, 82 is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 79 is found on the 16th try, so we have 16 tries. And then we output the array. Now this part here is output using a separate loop in a separate method called display array, which we'll look at shortly. When the program is done, we always output done. Let's look at the code. Before we look at the logic, programming logic, it's important to note that here in Java, we're writing this in Java, you have to import java.util.random library. We instantiate a random class into an object, RNG, that's our randomization object. New random. This is how we refer to it in the code. Into num, that's going to be the random number. That's where we're going to store the random number that we generate. Max equals 100. We're going to use that when we use the random number generator. Here's how we use the random number generator to generate random integers in the range of 1 to 100. Random number generator, RNG. Next int, that's the method in the random number generator we're going to use. Max plus 1. This combination gives us random integers in the range of 1 to 100. Now here's our code. We already have is prime. We've worked on that in class. In our main method, public static void main, here's the declaration of our local variable num. Num is going to store the integer we obtain from the random number generator. Here's our instantiation of the random number generator. That local variable is called RNG. That's the object. Random is a class, right? RNG is the object instantiated or created when we instantiate the class random. Here is our max value that the random number generator is going to generate. We're going to use that in our next statement with the random number generator. Here's our array size. This is how many prime numbers we're going to find. Notice it's final. It has to be final in order to use it in instantiating our array. This is our integer array, prime array. That's what we're going to call it. We could call it anything we want, but we want the name to mean something. Int prime array equals new int array size. There's the size of the array. And here is declaring or allocating size of this array. Int prime count. Initialize it to 0 because we haven't found any prime numbers yet. Int try counter. Initialize it to 0 because we haven't tried any yet. We haven't used any calls to the random number generator. Here's our output to the user. This is a comment describing how we're going to use the random number generator. And this is our use of the random number generator to generate numbers in the range of 1 to max. Now we have a loop. And this loop is checking prime count against array size. Now notice it goes less than, not less than or equal. Array size is 5. The indices will go from 0 to 4. That's 5 elements. Always the first element in an array is index 0. So while prime count is less than array size, so prime count is going to go from 0 to 4. First thing we do is increment our try counter. How many times we're attempting to get a random integer. This try counter is relative to this attempt right here. Here we output the number that is generated, which is what we said we would do. We would output the numbers as they are generated. By the way, it's important to note that no data is input from the keyboard in this program. In part of the description it says each number is displayed when it is generated. That's this line right here. Output the number as it is generated, sysout. And then we test it. Is the number prime? Using our isPrime method. If it is prime, then we're going to output that prime number as being prime. So prime numbers are output twice. Once when they are obtained from the generator, and then again if they are prime and they are identified as prime with this statement right here. We add them to the array, and then we increment the prime count. The prime count. Remember, prime count starts off as 0, so the first prime number is stored at sub-0. After the if statement is complete, when checking to see if the number is prime, we obtain another integer from the random number generator, just like we did before we entered the while loop. This is a standard practice in terms of a while loop, getting input, test the input, or test some condition, getting input, test some condition, do the work on the first value that was obtained, and then get another value. Again, note that the input does not come from the keyboard, the input comes from the random number generator, RNG. When this loop is finished, we output how many tries it took to find the 5 prime numbers, the array size, or whatever the array size is. If we change array size to 10, then this would change the output to 10. But in our case, array size is 5, so it's going to say 5 prime numbers found in try counter tries. And then we call this method display array, and then we output done. Let's take a quick look at display array. Display array receives as an argument an integer array. Really what this is the base address of an array. Int, and then A followed by these brackets tells us that whatever we want to call it, we could call this zebra if we wanted to, but we called it A. Int A followed by square brackets is the base address of an array. That carries with it a property called its length. We could write a for loop locally declaring the loop control variable I. For int I equals 0, it will start at index 0, while I is less than the length of the array, a.length, again that's a property of argument A, I++, output that element of the array, followed by spaces for spacing purposes, and then we put a separate new line character after the array is output. Let's look at the output of this program. Again, here's a sample output we looked at. Integer values are output as they are obtained from the random number generator. When prime, they're identified as prime. After the 5 prime numbers are generated, we output that count 5, followed by the number of tries which we accumulated in our loop. There's our results of display array. Done. This concludes this video.